Computer science students learned the word algorithm early on. But because of social media, and especially TikTok, most people nowadays know that these huge platforms use sophisticated systems for algorithms that employ machine learning and artificial intelligence to personalize content for them. But what is algorithm? Algorithm is a step-by-step process or the set of rules that manipulates input to solve a specific problem. Therefore, recipes can be considered algorithms, and just like there's many ways to cook something, there's also many ways to solve a computational problem sometimes, and that's where the big O notation comes in.
The big O notation is used by programmers, computer scientists, and software engineers to describe the efficiency of an algorithm from a space and a times perspective. As the size of the input gets bigger in a function, the big O notation describes the behavior of that function. It's also used to compare the efficiency of different algorithms or data structures so we can choose the best algorithm for that specific problem. One of the most common time complexities of an algorithm is O1, which means that it's constant time, that however big or small the size of the input is, the running time will always be the same. The best example for that is adding an element to the end of an array, because you wouldn't need to access every index of that array to add an element at the end. That's why it would take the same amount of time for any sized array. A simpler example of that would be to grab one item from the fridge. It wouldn't matter how big their fridge is, it wouldn't matter how many items are in the fridge. Grabbing one item from the fridge would take the same amount of time despite all factors. Another common time complexity for an algorithm is linear time complexity. This means that it's directly impacted by the size of an input. That means that the time complexity of this algorithm is directly proportional to the size of the input. The best example for that is adding an element to the beginning of an array, because that means that you would have to push every other element to its next index, which would take the amount of time in or the input is. And a simpler example of linear time would be peeling a batch of potatoes. The time and the space it would take you to peel a batch of potatoes depends entirely on the amount of potatoes. Another common big O notation would be the logarithmic time complexity. The time it takes to run an algorithm with this time complexity is proportional to the logarithm of the size input. This means that the logarithmic time complexity grows more gradual as the input size grows too, but it is still less than linear complexity. The best example of that would be binary search. Binary search takes a sorted array and compares the middle element of an array with the target value. If the target value is smaller than the middle element of the array, that means that it's definitely in the left half of the array, which eliminates half of the search space every time you repeat this process. Think of someone that wants an eighth of a cake. They would cut the cake in half and cut that half in half and cut that half in half, and that is logarithmic time complexity.